Continuing with the weather review, we have these air masses. An air mass is simply a large body of air which has generally uniform temperatures and humidity. We name them from their source region. They are sitting over a region of the Earth and picks up the characteristics of that region. So it makes sense when we call them, there's some of the names are maritime tropical, so that would be a maritime tropical would be MT, maritime tropical, maritime for ocean, and tropical is near the equator. So warm, moist air. Or Arctic continental, which is up here, way up here. Arctic continental, so over one of the Greenland or Antarctica, either side. Or continental polar would be over northern Canada, CP, but there's one over Russia. Then we have continental tropical, so we're down here in Australia, continental tropical, hot, dry air. Continental polar, generally cold, dry air. In Mexico we have continental tropical, so relatively dry compared to the maritime. Basically, these are the names for them. Okay, don't need to really memorize them, but just be aware that sometimes these air masses. That's the big point, is these air masses will slowly move, sometimes not quite slowly, but they'll move. So a dry, colder, continental polar mass might move towards the ocean and towards maritime tropical, and that would cause a cold front that would entail a lot of precipitation, etc. Or another example might be a dry, warm continental air mass over Mexico may move up to this is more typical, may move up over the Midwest U.S. and cause hot, very dry weather for an extended period of time. So they affect where they end up or where they're moving. They're going to affect the weather of those places. A maritime tropical air mass from the mid-Atlantic Ocean moves up the east coast of the U.S. This happens all the time. Dumps massive amounts of rain because it's pushing against colder air, and as that warm air is pushed up, starts raining, of course, and flooding for that matter. Or sometimes there'll be a moist or maritime tropical air mass, like over the Atlantic this way, might be pushing into the Atlantic around where we are, and if the land is colder or cooler, then that air mass might end up with fog, etc. I've always wondered if perhaps the Bermuda Triangle, that's this little area down in here, all the myth about that might just simply be cold air masses moving over this warm Gulf Stream. We have a pretty powerfully warm Gulf Stream current that runs past Florida in that area, the area of the tropical, or in the area of the Bermuda Triangle, just causing really thick fog. So airplanes and ships get so confused about where they are that they get lost. Don't hear much about that anymore. Anyway, that's my theory anyway. It's simply a weather confluence at that particular point. Carrying on, we have just a review again of this whole high pressure, low pressure cycle, right? Low pressure, warm air rises, moves over towards the high pressure. As the air sinks down, it compresses, gets denser. But because of Coriolis, it spins toward the right in the northern hemisphere and towards the left in the southern hemisphere. But we covered that. So then what we have when these huge air masses move, right? They have a tendency to bump into other air masses that are not similar, right? So this big air mass that has similar characteristics pushes into an area with different characteristics. This is an example of a warm front. Warm front, this is review, we've talked about it before. Warm fronts, that's the red with a red bump. That's supposed to symbolize warm air moving in a particular direction. And since warm air is less dense than cold air, it moves slowly, tends to move slower because it's got to push this denser cold air along. So we end up having a lot of weather over a fairly large period. So not only of time, but of space as well. So down here we have a weather depiction map at the bottom showing this warm front moving in this direction. The bumps are pointing in the direction that it's moving. And then we have all these little weather reports, and they're sort of, we don't read weather reports that much, but we have METARs over here. So, okay, St. Louis is right here. St. Louis overcast clouds with light rain. A little further out at Indianapolis, it's raining, 3-mile visibility. So back up, St. Louis, 1-mile visibility. Indianapolis, 3-mile visibility. Further out in Columbus, it's 6-mile visibility with haze. All right, so the weather's getting better out in here, but if they were to look up in the sky, they would see broken clouds. Yeah, here it is here. St. Louis, overcast at 1,000. Indianapolis, broken at 2,000. Columbus, overcast 6,000. But way out here in Pittsburgh, it's 15,000 scattered. So that's these little clouds up here, right? So we have this, the point is it has this large period of weather or frontal activity. Whenever two air masses meet, you end up with some kind of frontal activity, whether it's a cold front, warm front, and there are several other kinds that we'll cover in a second. Depends on what kind of air masses are involved and how they're moving, right? There could be a very dry, warm air moving across cold air, in which case there wouldn't be as much rain. Or it may be a tropical maritime air mass that is moving in this direction. It might be just loaded with moisture and you just have tons of rain. So there's some differences there. It all depends. All right. Warm air is less dense. It's forced up during this whole period here where the warm air is pushing. It's pushed up because the cold air is denser, so this warm air is pushed up. Whenever air is being pushed up, it tends to cool, and if it's an unstable atmosphere, it could result in some serious weather as well. This air is being pushed up until the warm air reaches its dew point or its 100% humidity point, and that's when the clouds form and rain may form as well. With the rain comes poor visibility over a long period. Right in here, it's all a fairly large area of poor visibility, stratus type clouds, but generally speaking, it's a relatively stable atmosphere because things are moving along fairly slow. Wind direction and the temperature will change, right? As you go from the warm air here to the cold air here, it's going to be a temperature change. Also, the wind direction will change, which is indicated by these little arrow things here. We don't really have one behind the front to show you that, but that's certainly a sign of a front passing as the wind changes and temperature changes. In some situations, the air over here, this cold air over here, where it's starting to rain, it might be below freezing. So if it's, minus 32 degrees, this rain as it falls through the here, it might turn into snow or ice pellets or slush or a lot of different possible things. Some kind of freezing rain, perhaps. And of course, ice on a drone is very bad. Water is pretty bad, actually, but there are drones that are certified to fly in light rain, but most people don't chance it. That's more of a military application. But ice is definitely bad. Ice accumulates on the propeller blades and on the aircraft and makes the aircraft heavier, and it accumulates on the propeller blades and changes the shape of the propeller blades, so that's not a good thing as well. Okay, so that's one kind. This is the warm front. Then we have a cold front. Cold fronts move faster because cold air is denser, so it's pushing this warm air, it's pushing it and moving it, and cold air tends to, like I said, moves faster, and so it tends to create an unstable atmosphere, in which case this warm air is being forcibly forcing up, and if it stays warmer as long as it stays warmer than the surrounding air, it just keeps going up till it gets to the troposphere, and that's what develops into a thunderstorm, generally speaking. Not always, but generally speaking. So the area of weather is smaller. It passes pretty quickly, as you've noticed probably if you ever check the Weather Channel or you sort of detect that. Weather moves along pretty good speed. This is, again, it's frontal activity. Cold air mass is pushed towards a warmer air mass. That's a cold front. We would expect in this whole area here more turbulence, towering cumulus. That's what these things are, towering cumulus. CU is the initials for cumulus, CU, and then T would be towering, and of course thunderstorms. Thunderstorms are TWR. That's the symbol for that. You must, for a thunderstorm to form, though, you must have unstable atmosphere. In other words, the air, the warm air, it continues to be warmer than the air around it, all the way up to the troposphere. And of course, same as warm front, they're right here at the frontal passage. When the front passes, the wind changes, and of course the temperature changes, most likely cooler. The same thing down here on the surface chart. That cold front is designated by a blue with pointy lines. That's supposed to imply cold or air. Moving much faster. You see the wind changes, temperature changes, a shorter period of poor weather if you go through all these here. Behind the front, St. Louis is behind the front. So it's moving, the front is moving that way. So behind the front, after it's passed, temperature is, where is it here? 8 degrees. In front of the front, it's 24 degrees. So there's 8 degrees of the temperature, 2.4, right, or 2. Here, over here in front of it, it's 24 degrees, and even further, it's 25 degrees, 24 degrees. So it's much warmer over here, obviously, because that's warm air, and a pretty drastic temperature drop. There's also pressure changes, too. 2983, 2974, 2979. There's some pressure changes as well. This part of the report is reporting heavy thunderstorms at Indianapolis. That's pretty close to right, well, there's Indianapolis right there. And further out in front of the front, haze, right? So there's a lot of weather changes, rapid weather changes in front of a cold front. And the big thing is, generally speaking, more severe weather related to a cold front. There are other kinds of, okay, let me mention this too. In a cold front, there's also this situation that's a more common situation. If the air is below freezing, if this cold air is below freezing, which again, it's relative, cooler air, as long as it's a little cooler than the warmer air, it's going to be a cold front. But if this is a, Arctic cold mass or even a Canadian cold mass moving in, if it's below freezing, as it pushes this rain, this moisture up, it condenses eventually when it gets high enough, and if it falls through this, it could turn into snow, of course, or ice pellets, or freezing rain, or further up when it's still warm enough, it might be rain. So there's all those possibilities as well. And this diagram is just showing the temperature, right? Once we get the temperature here, it can turn into frozen stuff. Freezing is a complex process. Pure water suspended in the air does not freeze until it reaches a temperature of about minus 40 degrees. This occurs because the surface tension of the droplets will, for a good while, inhibit freezing. The smaller and the purer the water droplet, the more likely it is turns into a super cold or super cooled freezing rain, right? So generally speaking, if there's a little bit of pollution in the air, there's a little pollen in the air, whatever, you're not going to end up with that, but it's possible. Okay, so moving right along here. So here we have a stationary front. We have a cold front moving towards warmer air, but for some reason the pressures somehow equalize. They both end up stopping, and that's represented by this line. It has the the blue pointy things, which is cold front, and then the red bumpy things, which is the warm front, going in opposite directions. So basically, these two air masses have stopped moving across land, but there is this disparity between the cold and the warm air is rising as it touches the cold air, so we have lots of rain staying in one position for lengths of time. We see this often over Georgia. Could be a couple of days, could be, 3 or 4 days, could be just one day. but it'll be on the weather charts. That's basically is characterized by rain showers, just steady rain for a length of time. Until, of course, it may happen, two different things could happen. The warm air might warm up the cold air, or the cold air might cool off the warm air, and once it equalizes, there's no longer a front there, it's just a lower pressure area. Or one of these air masses might gain some strength and push the other one out of the way. So that's basically a stationary front. Then we have an occluded front. We have two cold air masses of slightly different temperatures pushing together and pushing warm air aloft. So now we have this lengthy period of rain and poor visibilities as this one side does push against this slightly warmer cold air over here, trapping warm air above. Cold fronts typically move faster than warm fronts, so sometimes they will catch up to a warm front and pass it as these two fronts merge. Occluded front forms, according to this picture. At the front, the cold air undercuts the retreating cooler air mass associated with the warm front, further lifting the steady rising air. Clouds, precipitation occur in the area of frontal lift, ahead of, behind, and surface positions of an occluded front. So long-term weather. We have symbology here that you need to be familiar with. If you ever watched the Weather Channel, you're familiar with these signs. This cold front is the little pointy blue things, and the warm front is the roundy things. Stationary is opposite directions. Occluded means, give it this pinkish color here. And you can read the descriptions also. Occluded front, a composite of two fronts, as a cold front overtakes a warm front or stationary front. More symbology here. Low pressure, high pressure. Then we have these troughs, which are elongated areas of relatively low atmospheric pressure. And then we have ridges that are high pressure, lengthy areas of high pressure that are designated on these surface analysis charts or weather depiction charts. If you've ever watched the Weather Channel or any of the weather reports from your local news, you are familiar with these signs. Remember, just as a clue again, high pressure is trying to equalize to low pressure, but because of Coriolis force, the wind as it flows towards the lows deflected to the right in the northern hemisphere, and as air is pushing towards the low pressure, it's deflected to the right as well. So basically the air around a low is turning counterclockwise, and the air around a high is turning clockwise. Here is a weather depiction chart. Gives you a graphical indication of what to expect, where these high pressure, low pressure areas are. You see right in this area here, we have basically a stationary front, warm, cold, warm. We have high pressure over here, and these trough lines in here, low pressure, elongated low pressure areas, low pressure out in here. Let's see, things to note on this chart of significance to drone pilots are the fact that along in here we have, I'll stay with the red line, these are lines of equal pressure. As these lines get closer together, this just indicates stronger wind. There's a stronger pressure differential between these lines. So when the lines are close together, we have stronger winds. We have a large area out in here where these isobars, they're called isobars, are far apart. There's hardly any wind at this particular day when this was published, which is a 3-day forecast. Well, I don't see a date. Whatever day that was, there was no wind in Texas. In this area here, dead calm. I imagine that was probably in the summer. Okay, so those are isobars. That's something to note. Just equal pressure lines. And they'll even write them on there. Yeah, this one here, 100.4. That's millibars. They're typically in millibars. This whole line that goes around like this, that's equal pressure lines. Again, the significance is when they get close together, that's a lot of wind. When they're far apart, there's not much. Okay, look up here. It's blue. Up in this area here, look at how close they are over here in the northern Pacific. Pretty close together, lots of strong winds. The millibars is 1013 millibars is equal to 29.92 inches of mercury. So that's standard pressure, right? Should be familiar with that. Here's another chart from the national, from NOAA, actually. And this is Tropical Storm Anna right in there. Let's see, when was that? That was back in 2015. One of the deadliest recorded cyclones ever to make landfall around Myrtle Beach. So you can see the millibars are very close together around the hurricane. And if you can read it, the pressure is very low. It's really hard to see that pressure in millibars, but here's one over here, 1001, very low pressure. That's a classic low pressure area. And right over here is a high pressure area. This low pressure area is spinning very rapidly like this. That's what makes it a hurricane. And this high pressure area is clockwise around this way. Strong winds. Of course, cold fronts, warm fronts, you can see all that. There's another low pressure up in here with millibars that are very close together, lots of wind. There's a lot of information down here that we could go through as well. This gives us May 2015, May 8th, 2015 surface weather analysis. Yep. And again, reviewing the charts, chart symbols. All right. We have an interesting chart here that I found, just the general weather patterns over the whole planet. Okay, so we have semi-permanent pressure systems in the summertime, and then we have semi-permanent pressure systems in January. So this is a typical weather patterns, year-long weather patterns as they change according to seasons. So you can basically see the typical weather patterns. They do change, but this will give you a general idea of what year-long weather patterns look like. All right. Remember, you need to study as much as possible the advisor circle 00-6 and do the quiz. I suggested you read those 11 pages of chapter 12 before the next class.